Good evening, sir. Now I'm going to be explaining my base paper. So my topic is application level optimization of big data transfers through pipelining, parallelism and concurrency. So I've basically chosen 5 reference papers, and those reference papers were belonging to the concepts of pipelining separately, parallelism and concurrency. So here we have a large amount of data, and in certain concepts only pipelining were used, and in the other parallelism was used. But over here we use all 3 together because it gives even better results. So that is the basic use of why we are combining all 3 together for getting better results. So as we know, there are a large amount of data sets in the data centers, and transferring them is a very difficult process because it requires a lot of bandwidth, speed, transmission. There are various criteria that we need to look into. So we use all these 3 mechanisms. We combine these 3 to get the better results. Here we see the older models that are already present: Globus Online, UDT, pipelining, parallelism and concurrency. In the previous models, there were some drawbacks like security, reliability. We did have some drawbacks, and further in these models, these drawbacks have come to an end. So here we see examples of parallelism and pipelinings. That is, what happens if there is no pipelining and no parallelism, and what happens if both are combined together, both parallelism and pipelining. So here we know pipelining is a very useful tool when there are small number of files, but when it comes to large number of files, we see a bandwidth delay happening. So in order to avoid that, we go into the combined model, which is mentioned in this base paper. Parallelism, in the other side, it is also it works well in small number of files, as the same as pipelining. And parallelism is good only when we transfer large number of files, that is when it is in the combination with concurrency. If not, it is best only when we transfer small number of files. So in concurrency, the total throughput shows a linear increase. The number goes high, it comes closer to the network capacity, and the increase becomes exponential and then starts to decrease or takes the form of a steady state transfer. So when there is an increase in the number of files, we need to combine it with either parallelism or pipelining for it to form that steady state. So when there's a steady state, it can have a better performance than the existing models. It can have more speed, security. We can rely on it. There's a lot of reliability too. So in future, we intend to write an overhead-free implementation of grid FTP client to reduce the overhead regarding connection, startup or teardown processes for different chunk transfers. So right now, the application level transfer tuning parameters such as pipelining, parallelism and concurrency are very powerful mechanisms for overcoming data transfer bottlenecks for scientific cloud applications. However, their optimal values depend on the environment in which the transfers are conducted. So this is the existing system's conclusion, and the future is going to be grid FTP client. So thank you, sir.